Okay, take two. Hey, training plants every day. Jordan Scoble coming at you from the STEM lab here. So I just got a call from a temp service that goes through workforce up there in Delhi, and they were trying to hook me up through that dairy company up there in Delhi. Um, I don't exactly know what they do, but I know it's a dairy factory. They probably take raw stock dairy from some of these farms around the area, and they turn it into ice cream, yogurt, milk by the gallon. I'm not exactly sure. So I gave the guy my general resume, my general work order. He asked about Tompkins, Johnson and Rhodes, S&S, Knapp Woodworking, um, Deposit Lawn Care, and Devonian Stone, IWC, stuff like that. So I'm sure I got plenty of manufacturing and mechanical operating procedures, CNCs, and things like that. But the one thing he didn't really ask me, which I'm going to do in this video for you, is a lot about the STEM material and things like that. And again, if you watch some of my other video resumes, you'll know that a lot of this works out to be like a manager's conversation, a safety officer's conversation, because they really they come on a fine line between about the average being in the middle. You know, this is what the daily operating procedures are against companies that either are all manufactured out, pretty strict, this is what you do every day, it's this job all day, every day, to a lot of companies that switch out their products a lot, but have that same regiment to it, and against how fast you might need to do some of that stuff, because, you know, a lot of machinery is moving real quick here. Not necessarily for the safety of yourself, but everybody else around you, and as well the machinery that you're working with. You got to be able to stay in tune with, you know, the sounds and the sights, the things that are working there, because that all fits into one giant kind of box at the end of the day that you segment out, quantum physics, if you will. Anyways, the science, technology, engineering, and mathematics becomes this idea of science is analyzing your results, forming a hypothesis, which is in itself its own machine, and that becomes a technology. You know, the technology here becomes safety operator or manager or time systems, biometrics to your body, and any other variable that works out to be that it is engineered, but you're going to have to engineer yourself into doing at any one of these companies. And at the end of the day, you know, the mathematics really isn't all that important when you consider what mathematics is against, you know, mathematics is the same thing as science. Mathematics is a technology that was engineered. But basically, to form that out, it should go here in ones and zeros. I like to take that an extra step. It helps me form better results by, you know, writing them out. If I could write it out, then obviously I have it memorized. If I have it memorized, then obviously I'm going to be able to write it out, right? 1 and 0. That's the idea, and it goes to also the numbers that you're putting out. The product numbers, whether it be the average or you're getting piece pay for a company, and you got to be able to track those numbers efficiently against your engineered system, or working your biometrics to pick up a better number, or, you know, keep an eye on the machinery to make sure it doesn't break down, or so you can kind of predict the future a little bit, so you can say, well, this machine needs maintenance, or it's going to need maintenance. Not only does it cover the machinery to keep everything running as efficiently as possible, but it covers your own ass, so that way you don't get checked for breaking a piece of machinery because you're going on it too hard, or, you know, and that's a safety concern as well for a lot of other reasons. Um, but again, usually in high-end companies and things like that, it usually works out to be a level of biometrics to what is approximated to a level of assembly. Now, assembly can be a lot of different things. I've worked on a tread line. That's more of a manufacturing system, but it follows the same regimen as assembling an IKEA table leg a million times during that day. That takes 10 pieces to put together to make that table leg. That's the level of assembly. A tread line taking the stone, loading it on the bays, rolling them down, using the suction lift to put them on this other machine by two, and then rolling them over to use the automated burner to burn them, or hand burning them, depending on which way you're going to go about it. Hand burn them first, use the suction lift to put them on the roller, and then either hand cut them or press a button to use a saw to do it, roll them over, burn off the edges, and hand carry them over, whatever the variable may be. It's basically take this screw, put it in here, do this, and work that process. And they need a level of science, technology, engineering. Each one, tread line, table leg, that's the science. We're analyzing that example. We're saying this is what I have to engineer, or this is what the company would have to engineer. The company already engineered it, so now I'm going to come in there and I'm going to engineer myself to do this job, right? That also can be tweaked a little bit as well. A lot of laws in quantum physics can be broken down. You would say the timelines, the parts per million, the things like that. And again, some companies have this power series pretty much locked out. Not all of them. Some companies, given the job that you're doing and the process it takes, you'd be amazed. Even on a tread line that looks very manufactured out and very all worked out, you can bump up this rating a little bit. There's little windows of, like cleaning out all the slag and how well you work the machinery that loads the bays and picks up the thing, cleaning the stone. Those things don't really look like they need to be worked out, but sometimes they really do. With that being said, dirt on stone that's frozen sometimes takes a little bit longer to clean off than other things, but you're still working out, can I do this in 5 moves? Instead of just da 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 da. It looks clean. You want some kind of robotic manufacturing system to go with it. So you look at it, you analyze it, you engineer something to it that becomes the new technology that you put in there. Just like building a new machine that does that for you, that cleans it all off. It's very mechanical in quantum mechanics and things like that here. Again, because each are their own particle into a larger stone dock or company, whatever the case may be. Mason. I can predict the future by knowing those numbers. I can read somebody's mind by knowing, well, you didn't do those things, so don't lie to me. Kind of a conversation. With that being said, obviously that's not where I'm starting. You always gotta build that. Every time you meet somebody new, one, so they know you have it. That helps you get those raises and promotions, and the other, so they know you have it. Because you don't, as a person to person, even on the street or something like that, you want to build that. You want to make sure that you're, more of the general relativity, and that puts you at a higher standard. Honestly, it's just one of those things. You try to make the best friends you can. You live in that anthrope the best you can, but who willingly would want to be at bottom when equal or better are always options? And you can be better and maintain equal. You can say, hey, we're buddies. I don't want to push that equal model, but I'm not going to let you take my thing by screwing up numbers and drop me down any more than you need to. If that winds up being a position, because you got to work with people, do group projects and things like that, you got to know those numbers. It covers your ass. And we're not just talking about losing digits and things like that, but comes into the digits that work in other ways, personality, all kinds of different things. So again, STEM here is what I call this. Some people call it manufacturing skills, managerial skills, safety operator skills, OSHA needs, things like that. Just generally working a company, building your company. This is all STEM. You're starting with small points, whether it be whatever that point may be at the quantum physics level of the universe, right? Your resources and what you're good at, your resources and what you can do to make money. They're two different things. But at the end of the day, even though you're going to say, well, that's not what I like to do, that's not what I'm good at, you might find that you're better at it than you think by tweaking these things out just a little bit. Money's money at the end of the day. That's why you do this. You don't necessarily do this to, hey, people may disagree with that statement, but it is what it is when it comes to me. But again, like little things that you can do at the end of the day, just little tiny seed elements that have very systemic effects. How you hold your body, where you keep your razor blade to cut stickers and plastic and your markers and your pencils and your pens, everything like that. How you jump on and off a forklift. They add milliseconds to a system, and not only add milliseconds, can make sure that that process is more safe and efficient than just not really taking in consideration those things. Or I'm over at the bays doing one thing, or I'm loading tables. They both have, while they look exactly the same, have very subtle differences about them and how you have to work those manufacturing processes, because at the end of the day, that's what they are. It may look like you're hopping up and down, and other than that, that's the only thing that's the same. Other than that, how this stone loads up, how you have to look at a specialty cut and then say, well, I know the common factor. Now let's take that and say that this is going to take 2 extra steps to do that, and I will do that every single time as long as I'm working this product. And again, in very large end companies, that's what is done. And you have to be able to pick up on that and be able to stay within that process. With that being said, there's always room for improvement if you can have the time to be able to work out one of those subtle differences. Again, most stuff, it's the only thing common about common sense is the lacking of it for the most part. Um, but with that said, a lot of these places, they already got that stuff knocked out for you. They'll teach you that stuff in the regular training model of it, and anything you do away from that model is going to slow you down. Um, that's usually the general model of it. And a lot of companies that already have this worked out, high-end OSHA, already come through, and they already know this is where the hammer goes, this is where the chisel goes, or this is where the hose goes, and the nozzles, and you got to keep all that stuff worked out. And again, I'm trying to integrate it to what I think this new company that I'm potentially maybe going to get the call for would be asking. Again, they probably already have all that worked out. This is one of those kind of companies that it's probably essentially even the human body is going to be automated into this system. And there's really not going to be a lot of room for error, not a lot of we're behind orders. This is kind of what those machines can do with this process, and it's probably already worked out. So you're just coming into work and filling that void, which no real machine can do, whether it be just for that machine, whether they haven't upgraded to automation that can do that yet, or this one person does this and 10 other things during that day. It's basically a machine that can do that even a manager can be an automated process. You just fire the manager and you tell all the regular workers when this machine comes through, it don't care, it's not going to stop for you on the forklift. You just got to watch out for that thing, unless you build some kind of sensor for that thing that can do that for you. And again, that's what a lot of this automation is about. If you could figure out, those specialty things, it's just really hard to CNC a program that does this kind of specialty thing. If you ever watch robotics or something like that, just how to walk upstairs. And when it comes to programming robots and the language you have to speak is incredibly difficult. It takes thousands of millions of lines of code to be able to work all that out. Because a lot of this, again, you got to study Mini a Bitcoin, which is a programming game of 13 megabytes or that's Hunter's Prize, excuse me, in mathematics, of 13 megabytes down to smaller than 13 megabytes, which is an incredibly difficult thing, because you're dealing with a lot of problems. Mainline energy coming from the waterfalls that gets come down to a machine that might have a program housing system where you load everything into there, which is where most of this happens, the CNC machine, or some kind of machine I can plug into that, which is a smaller program bit, which takes up too much time to do this, and again, is not exactly making a computer smaller, faster, more efficient. It's just saying, well, for what it is, I can make it smaller, faster, more efficient, which is just 3 megabytes, 3 particles at the end of the day, which it gets weird in quantum physics, and I'm not going to really break that down to you right here. But anyways, always be aware of your safety, have your safety gear with you, some level of first aid quick kit, or know where it is. you know, because you never know what's going to happen. Um, but other than that, that's kind of what general time STEM is. So, catch you on the next one.